Alright, we are studying Unit 9, and we're talking about polygons and mostly quadrilaterals, but we're going to start off with just the angles of polygons. And so that's what this first lesson is about. Our goal is that we can find and use the sum of the measures of interior angles and exterior. So when I look at angles on a polygon, see if I can draw one here. It's not the best. But anyways, as I look at this angle, there's two parts. There's the inside, and then if I extend out the side, there's an outside. So we're talking about both exterior and interior angles when we're looking at these angles today. So we're going to look at, with the interior angles, we'll talk a lot about diagonals. So when I'm talking about, again, polygons, I can draw diagonals from any of the vertices to another vertices. If I drew it to the one right next to me, I just draw the side. So those are what we're looking at when we talk about the diagonals in there. So we find from doing that and from the activity that we saw yesterday in class that the sum of the interior angles is the measure of their sum is the number of sides minus 2 times 180. And the reason that is because if I draw these angles out, the diagonals out, I see there's 3 triangles when I have 5 sides. So there's 2 less triangles than there are sides. So that's why we take that times 180. So we want to first find the sum of the measures of a convex nonagon. So we have to talk a little bit about the again, I think we've talked about it before, but how the polygons are named. Remember, they're named by their side. And 3 sides we've talked a lot about are triangles. 4 sides is a quadrilateral. 5 sides, pentagon. I'm going to spell that right. 6 sides, hexagon. 7 sides is a heptagon. 8 sides is an octagon, and 9 sides is a nonagon. 10 sides is a decagon. And 11 is actually, most of the time we'll call it an 11agon. 12 is a dodecagon. Sometimes 11 will be called a hendecagon. So if you don't know those, that might be something that you'll want to do. But anyways, we see here we've got a nonagon, which is going to be 9 sides. So their sum is going to be 9 minus 2 times 180. So 7 times 180. So you'll multiply. You want to first remember your order of operations. So you want to always do the subtraction first, and then multiply 7 times 180, and you get 1260. So the sum of all of the interior angles is 1260. And then if it's a regular polygon, then it's going to have equal angles. So add it all together, we'd get 1260 because we can see that we can make 7 triangles. So now we can use that concept of their sum here when we have expressions. So we know these are equal, but that doesn't help us to put those equal. But we know this is 4 sides, so the sum of the interior angles of a quadrilateral is 4 minus 2 times 180, or 2 times 180, which equals 360. So all of these added together equals 360. So I can go ahead and write my equation as 11x plus 4 plus 5x plus 5x plus 11x plus 4 equals 360, because we know that their sum is totally 360. So I can take all my x's, add those together, so 32x, and plus 8 equals 360. Subtract 8. Let's put this over here. 32x equals 352 and then divide by 32. X equals 11. So we have x, we want the measure of each interior angle, so we see that this one is 11 times whatever x is, which we found to be 11 plus 4, so 121 plus 4, which is 125, and this one is 5 times 11, which is 55. So these two both are 125, and this one is, these two are 55. All right, so that gives you kind of the basic of those two types of problems that you're going to see is their sum and also the measure, then also using that sum to figure out, well, like this would add up to be 360, finding x, and then finding sometimes the value of each angle. So next we want to talk about just kind of putting that to use a little bit. A mall is designed so that the 5 walkways meet at a food court. That is the shape of a regular pentagon, so that's 5 sides. Find the measure of one of the interior angle. So now I'm just looking for one. Well, we can find what they all add up to be. So by taking 5 minus 2, number of sides minus 2, always minus 2 times 180. So 3 times 180. 540. And then since this is a regular pentagon, that means each one of these 5 angles is equal. So if they all add up to be 540 and they're all equal, if I divide that by 5, that tells me the measure of each one, 108 degrees. So 7, subtract 2, you get 5 times 180, and then take that total and divide it by your 7 for each interior angle. So next we're going to talk about if I know what the angles are, which the interior angle each is, then can I find the number of sides? So we know that the interior angle of a regular polygon is 150. So what we just did is we took the number of sides, which I don't know, we subtracted 2, multiplied that times 180, and then we took whatever that sum is, and we divided it by n to get 150. So if I multiply 150 times n, that's going to give me what the sum is. So then I can distribute this out. So 180n minus 360 equals 150n. And I can subtract that over. So 360 equals 30n. And then divide by 30. So I get 12 for my number of sides. So again, I would take the number of sides, which we don't know, minus 2, and times that times 180, and that will give me 144 times the number of sides, because this would be my sum of the number of sides. So there's 2 ways I can find the number, the sum of the sides. I can find it this way, or I can take the angle times the number of sides. And again, distribute this out, and I want you to notice that every time I distribute this out, I get this 360, and kind of remember that as we continue on in this lesson when we talk about exterior angles, because you're going to see that 360 quite a bit in exterior angles. All right. So that's kind of the sum, or kind of the sum of all the interior angles, kind of the point of interior angles. Now let's talk a little bit about exterior angles. And there's just one theorem, and I can remember this. I like to remember it because I think of like exterior, things of Xbox. 360, I know it's pretty old, but anyways, that kind of helps me remember. But exterior angles always add up to be 360. It doesn't matter how many sides. If I take all the exterior angles, they'll add up to be 360. And notice, again, when we were doing this, the problem, when we were finding the number of sides, we saw that 360 quite a bit. So there's another way we can also find the number of sides. But here, all of these sides are going to add up to be 360. So I can add all these sides up. 5x plus 5 plus 5x plus 4x minus 6 plus 5x minus 5 plus 4x plus 3 plus 6x minus 12 plus 2x plus 3, and we know they're going to always equal 360. So let me add up my angle, or my x's. So 15x, 25x, 31x, and my numbers here, minus 12 equals 360. Add 12 to both sides. 31x equals 372, and then divide by 31. X equals 12. So we can set up our equation with that 360. But I also want to just kind of go back to this problem here. And we know this is your interior angles. Well, the interior angles with the exterior angles make 180. So if the interior angle is 144, then this exterior angle, so just another method I could use to solve this, is 36. And I know that 36 times the number of sides will equal 360. For the exterior angles always add up, so if I take 36 times the number of sides, so then I can just divide by 36, and you'll see we get the same thing. So you could do either method when you're solving those problems. All right, that's the lesson. If you have any questions, make sure you ask, and I hope you are having a great day. Bye.